A roots question here. We're starting at A, we're going to have to get to B, and we either go down or to the right. So this would be one possible route, and you could say that would be a starting point for this question. Can you find any route at all that sums to 51? Now, we also know that we're adding the numbers up, but we're adding 5 for every black square. So that is another thing to think about, really. Like, is there a way of only going through one black square, or can you go through loads? Actually, if you take a little look at it, we're always going to go through 4, because you're going to go through sort of 2 on the way down and 2 as you go to the right. Um, it's necessarily going to be 4. So that's kind of like a bit more insightful into dealing with this problem, because it's not just about finding a route, it's how many there are. So we must pass through 4, or exactly 4, black squares on our path. And then each one is 5, worth 5, so 4 times 5 is 20. Therefore, the remaining numbers on the path must sum to 31. Because we've got 20 necessarily from the black squares, we need 51, so the rest must sum to 31. Now, there's no single digits, and therefore we must pass through 3 numbers. It's going to necessarily be 3 numbers every time. It's going to have to be a 10, a 10, and an 11. Okay, and this very quickly reduces our possible paths. So we could go along here and then down like that, or we could have gone to the right, but there's no way I could have got 11 there. If this one's going to be no good, because I can't, once I've got to that one, I can only go through 12 and 15. Or I could go down here, but then I'm going to have to go through the 13. So it's not possible really. And I think just drawing these on the graph is convincing enough. And so how many paths are there? There are no paths. That's sum to 51. I really like roots questions like this, and so yeah, hope you enjoyed it as well.